Okay, this is the third in the presentation on Chapter 5 on probability distributions. And so let's go ahead and see if we can continue on with this. First of all, as we use a probability distribution, we need to know that the probability distribution consists of, the binomial consists of a series of Bernoulli experiments. A Bernoulli experiment is a simple experiment that only has the possibility of two outcomes. Flipping a coin, heads or tails. The gender of a child, male or female. Improved or not improved. And yes or no. Success or failure. So that is going to, a Bernoulli experiment is going to be one trial, one situation. Then a binomial is going to consist of multiple Bernoulli experiments. So the binomial probability distribution is going to have these characteristics. It's going to have a fixed number of trials. That is, we're going to flip a coin 20 times, 15 times, whatever. The trials are independent of each other. The answer, the result on the first trial has no effect on the result on the second trial. Each trial has two and only two possibilities, and the probabilities are constant for each trial. When we flip a coin, it's the possibility of heads or tails. The heads 50% of the time, tails 50% of the time. So that's possibility of that the probability is going to be constant for each time. So that's what a binomial probability distribution consists of. Remember, we talked about it earlier in these sessions, that it was going to be a discrete probability. Now, the formula. And we used this in the last session, but we just sort of presented it, and we didn't do a good job of going through and saying this is what it is, okay? So here is the formula. The probability of x is going to be n factorial, n minus x factorial, x factorial. And we're going to recognize this as being the combination combination of n taken x at a time. Okay? That's the same thing that we had earlier. And then the probability of x, p raised to the x and q raised to the n minus x. So let's look at a couple of examples of this. Let's see how that works out. Let's just say that we're going to flip a coin 10 times. So that means that x is going to be equal to 10. And we're going to get n. Now, x is going to be 5, and n, the total number of flips, is going to be 10. Okay? So that combination of the probability of getting 5, the probability of x, let me back out just a little bit here, the other way. Okay, there we go. Yeah, we're getting there. That's going to be, the probability of X is going to be C of 10, taking 5 at a time. The probability, which is P to the X, Q to the N minus X, which is going to be 5 also. So put the numbers in, 10 taken 5, 0.5 to the 5 times 0.5 to the 5. Okay? So this is going to be 10 factorial divided by 5 factorial, 5 factorial. Both of these together will be 0.5 raised to the 10. And since I'm going to do another problem in just a minute, it's going to be good to use whatever information we can use for the second one. So that's going to be, let me use a shortcut, 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 times 4 times 3 times 2 times 1 times 5 factorial. This 5 factorial comes from here. So these cancel. 0.5 raised to the 10, according to my handy dandy calculator, is 0.0009765. And hopefully that's right. So we can go through and cancel. Cancels with a 2, that cancels with a 2, that cancels with a 3, that cancels with the 2. So it looks like I've got 6 times 42 times that number. And I didn't bring my calculator for that. So looks like it's 252 times 0.0009765. And I believe that that's going to be equal to 0.246, which means about a quarter of the time, if you flip a coin 10 times, about 1/4 of the time, you're going to expect to get 5 heads. And that's reasonable. And then it's going to actually go down a little bit, just like it did with the rolling the dice. You're going to expect to have fewer times when you get 1 head and fewer times when you get 1 tail, but somewhere in the middle you're going to expect to get maybe 4 to 6 heads most of the time. So that's how that distribution plays out. Well, I'm going to end this one and actually continue on and talk a little bit more and about this in just a minute. So we're actually going to do a fourth one.